All right, hey guys, it's Miss Summers with your notes today on factors that affect climate. By the end of today, you'll know the 6 factors that affect climate and how they affect it. If I give you a location, you are going to be able to tell me what the climate's going to be like given a certain set of factors. Okay? Before we start this, I want to talk about the difference between climate and weather. It's one of the things that you got to know to get through this class. And it's a good thing to be able to differentiate because as you get older and you start having discussions and you hear people having discussions about climate and climate change and weather and things like that, you'll be able to pick out, okay, that makes sense, or oh wait, that's not what that person thinks they're saying. They think they're saying something different. Okay? So let's look at that first. Climate is a long-term pattern of weather. Okay? So when we say long-term, we don't mean like a month or 2 weeks or a week. We mean years, decades, 10, 20, 30, 40, hundreds of years. That's what climate is. Weather is the atmospheric conditions that we experience, like pressure, humidity, temperature, from day to day, and it changes day to day. All right, so I like these two visuals to kind of give you an idea of how to think about climate and weather. Climate is your playlist. Weather is the song that's playing right now. Okay, so think about like your favorite type of music. Okay, you make like the ultimate playlist on Spotify. Okay, Miss Summers would probably listen to like heavy metal. Okay, heavy metal is my climate. All right, because all the songs have certain characteristics that I'm going to find throughout. All right, each song sounds different. Each song is different, but on average, they're all pretty similar. Okay, if you listen to my heavy metal playlist and I throw a country song in there, you'd be like, well, that's weird. That's unusual. That was not predicted. All right. One doesn't really affect my playlist or my climate. Okay. But if I had a whole bunch of country songs, you'd be like, wait a minute, that's changing. That's weird. Your playlist is changing. Haha. There we go. All right. This other diagram, we have this guy walking a dog on a beach. The guy is walking in a straight line and the dog's kind of like going back and forth. All right, climate is predictable. Okay, if we kept following this guy would continue to walk in a straight line. We're pretty sure that's where he's heading. Climate is predictable. Weather is variable or unpredictable. It changes day to day. That's why, like, the weather person, okay, meteorologists, they get a lot of flack because they're like, why can't they get the weather right? Because there's a lot of factors that change weather. Weather is very volatile, okay? It changes, okay? But this weather is staying kind of around this line, around this climate, okay? If this dog started walking like way the heck out here, this guy's path would also probably change. Now the climate might be shifting. All right, I've included this meme. I usually post this every winter whenever we have a snowstorm. People confuse weather and climate. They don't understand there's a difference. So they're like, oh, it's cold today. It's snowing. Therefore, climate change or global warming, that's not a real thing, right? Because it's snowing today, right? No. Snowing today is the weather condition. Climate is the long term. One day of weather does not determine what your climate is. Okay? Again, when we're looking at climate and climate change, which we will look at tomorrow in detail, climate change has to do with temperature and precipitation shifts over several years. All right? So one day of weather cannot determine what your climate is. Okay? So don't fall into that trap. Okay? Know the difference. All right. So now let's look at our 6 factors that affect climate or the 6 factors that affect climate. Actually, JK, let's look at the characteristics of climate, LOL. So climate is going to be described as precipitation or temperature. All right, so not only how much precipitation do I get, but when does it happen in the year? Does it happen throughout the whole year, or does it happen only in a certain season? Same with temperature. I'm going to look at what's the average temperature. How does the temperature change throughout the year? Does it stay the same, like in a rainforest? Or does it get warmer and then colder, like it does here? That's what we're looking at when we're looking at climate, okay? So these 6 factors that we're about to look at are going to change these 2 thingies, all right? For each factor, I have stuff for you to write down and also pictures, all right? And I'll let you know which pictures I want you to draw, okay? All right, so our first factor, we're going to remember this cutesy little acronym, LAMO, that we came up with a couple years ago, LAMO. The L in LAMO stands for latitude. And we learned about latitude at the very beginning of the year. It is how far you are from the equator. And you probably remember this. The farther you are from the equator, the colder it is. And that makes sense. You might, in the summers, I already knew that. Canada is colder than Florida because Canada is further up north. The South Pole is colder than Australia because Australia is closer to the equator. All right, that does affect temperature, but latitude can also affect precipitation. All right, so almost all tropical rainforests, which have a hot, humid climate, most of them are at the equator, which is right here, while most deserts are at 30 degrees latitude, either north or south. Deserts have very dry climates, very little precipitation. This is due to these things called Hadley cells, okay? And if you remember from Monday, you talked about air pressure. In your assignment, there was a picture of one of these thingies. All right, basically what's happening, because the equator heats up more, because it's always facing the sun, the air pressure here is lower. Remember, at low air pressure, air rises and it condenses, and that's why we get rain. That's why there's rainforest, okay? This air is going to push either to the north or to the south, and it's going to increase, it's going to sink, it's going to cool off and sink high pressure at 30 degrees, okay? So latitude affects Hadley cells. All right, this is a picture I want you to draw. Again, the most important thing is the temperature, which you should already probably have in your mind. All right, around the equator, we have the tropics, which are very warm. Between the tropics and the and about 67 degrees north or 67 degrees south, we have temperate zones. This is where we live. So temperate, it's not too hot and it's not too cold, somewhere in between. And then at the very top and very bottom, we have our polar regions. All right, and polar, just like a polar bear or a polar air mass, is cold. All right. Put a star next to latitude. Latitude is the most important factor in determining climate. Latitude is the most important factor. All right, let's move on to our next factor. Oh, JK, let's look at an example. Miami, the average temperature of Miami in May is 81 degrees. All right, we know Miami's in Florida. It's at the very southern part of Florida. So close to Cuba? Yep, that's where it is. New York City, same longitude, different latitude, is only 72 degrees. All right? Closer you are to the equator, the warmer it is. That makes sense. All right, next factor, A, is for altitude or elevation. You could write either one. I will use them both, so just know they're synonyms. Your altitude is how far you are above sea level. The higher the altitude, the colder it is. I want you to draw this mountain. I don't care if you draw the giraffes. If you want to draw the giraffes, go for it. But draw the mountain, okay? You might be like, wow, this place looks really warm. Like, these giraffes looks like they're having a great time. But there's snow up yonder. Even near the equator, high altitudes will be cold, okay? So, this is Mount Kilimanjaro, which is in Africa, which is 3 degrees south of the equator, so very close to the equator. This is the tallest mountain on the African continent, and that's why there's snow on it. Remember, in the troposphere, all of us live in the troposphere. The higher up you go, the colder it gets. So we already kind of knew this one. Cool. And again, here's the example. I just said that. Mount Kilimanjaro still has got snow because it's so high up. All right, next one. Water. This is our first W. There's 2 W's. Water, we're going to talk about proximity, or how close you are. Proximity means how close. All right, so proximity to water can change two things. It can change the temperature range, and it can change precipitation. Places that are close to water have milder climates. We talked about this when we talked about the sun. And we did that lab where you watched the video about the water and the soil heating up. All right, water takes more energy to heat up, so it doesn't change temperature a whole lot. Land gets really, really hot, and then it gets really, really cold. And it gets really, really hot, and then it gets really, really cold. So if you're near water, your temperature doesn't change as much. All right, that's why people go to the beach in the wintertime, because it doesn't get as cold. It's milder. That's called differential heating. The other thingy that you can get by being close to water is this thing called a lake effect snow, which is super fun. And by super fun, I mean probably really miserable. I don't even like snow that much. This picture is from a game. It was the Buffalo Bills playing the Indianapolis Colts, it looks like. And of course, they were playing in Buffalo, New York. Now, if you know where Buffalo is, it's right on Lake Erie, one of the Great Lakes. What happens, you get cold air picking up some warm water, so this would be the Great Lake, and then it just dumps a ton of snow. So this football game was being played. I think it snowed something ridiculous, like 3 feet over the course of like the time this game was played. And like they're constantly shoveling out, like super fun to watch. I'm sure it was not fun to play in. Super fun to watch on TV. Okay, the picture I want you to draw is this image on the left. And you should already know this image because I think we used it in astronomy. I do like recycling images because things tie together. Okay? San Diego and Dallas are on the same latitude, so they get the same amount of sunshine. But because San Diego is near water, the temperature doesn't change as much. Dallas, it gets really, really cold, and then really, really hot, and then really, really cold again. It's because Dallas is inland. On the water, not so much. All right, so we have latitude, which is our most important factor, altitude, and how close we are to water. Something else that can change precipitation is a mountain. All right, I'll give you a second to write down these words. Windward and leeward. So these terms, okay, these are terms that we're going to use when we're talking about a mountain that's facing water. So the windward side is the water side. It's the side that's facing the water vapor. And as the water vapor lifts, so air is pushing inland, it's going up the mountain. We're going to get something called orographic lifting. That just means the air is rising because it's running into a mountain. That's all that means. That's going to make clouds. Okay, so on that side of the mountain, it's going to rain a lot. You're going to have a lot of precipitation. It's going to be very wet. Once the air dumps all the water off on the windward side, well, now the air is dry. And this dry air is going to come over the mountain, and you're going to have less precipitation. So this is the picture I want you to draw. Words. Okay, so here's our ocean. This is the windward side because it's on the water side. All right. So as this moist air rises, that's the condensation. There's precipitation. So you're going to have a lot of green on this side, a lot of forest, a lot of plants. There's not as much water on this side. This side is going to be drier. Usually you're going to have like arid or desert conditions over here on the leeward side. So windward is wet, leeward is dry. All right, our last two. Our next one is ocean currents. And we already talked about this. We talked about this last unit actually, so pretty recently. Ocean currents affect the air temperature of their locations. Okay, so you can have two locations on the same latitude, but if one is on the warm current and one is on a cold current, the air temperature will change. So Brazil, we already said, we looked at this in that ocean currents exploration assignment. Brazil has a warm climate because it's on the Brazil Current. That's warm water coming from the equator down the east coast of South America. But on Chile, on the opposite side of South America, Chile is on the Peru Current. which comes up from Antarctica towards the equator. That's cold water. All right. The main example, I know this is not a great picture. You don't have to draw it like exactly like this, but if you just want to draw like a blob to represent like North America and then like a blob to represent Europe, I would be happy with that. The Gulf Stream takes warm water and moves it over towards Europe, particularly like the British Isles and like Western Europe. Okay. Whee. Like London, I don't know if you've ever been to London. Haven't gotten there yet. It will eventually. London's actually pretty far north. It's like on the same line of latitude as like central Canada, which is really, really cold. But London doesn't get super duper crazy cold in the winter because the Gulf Stream warms it up. Okay? All right. And our last factor. So we have latitude, which is the most important, altitude, how close you are to water, mountains and ocean currents. Our last one is wind patterns. All right. Wind patterns push weather systems a certain direction. All right. We're going to be able to predict where things end up based on wind patterns. So I got this GIF off of Google, actually. It looks like this is a cold front. I can tell it's a cold front because I have a line of severe storms. All right. It's being pushed from west to east. That's because the United States is affected by the westerlies. Starts from the west, pushes east. Okay. Go home, look at the radar. 9 times out of 10, something's going to be pushing west to east, west to east, west to east, west to east, west to east. And that's good to know because we can predict where things are going to end up in terms of weather. All right. So, this line of storms wasn't always over. This is Oklahoma, I believe. Yep, Oklahoma. Okay. This line used to be out over the Pacific Ocean. Okay. So by knowing where the wind patterns are, you can figure out where things are going to end up. All right. Here's a picture I want you to draw. Here's the pictures. All right. I don't expect you. I'm not going to expect you to memorize like the westerlies or the trade winds or like any of that mess. I don't necessarily expect you to memorize that. Just know that wind patterns push things. Give you a little recap from Tuesday. Remember we talked about hurricanes, how hurricanes are pushed by trade winds. All right. So hurricanes start in the tropics like this way, so they get pushed over here towards the United States because the trade winds kind of push generally to the east, and then they get picked up, these westerlies, as this hurricane moves, depending on where the areas of high pressure are, it can push them here, and then they get carried by the westerlies. Okay? All right, so those are our 6 factors. You know those 6 factors. You know the difference between climate and weather. All right, so go ahead and get started on your assignment. Let me know if you have any questions.